The concept is simple. Just add the forces to 0 and get the equations for x, y, and z. It's the execution that's a little hard. So we'll look at two example problems, fundamental problem 3.7 and fundamental problem 3.11. In this problem, we need to have the forces add up to 0, and there are three unknowns, F1, F2, and F3, which is perfect because we'll have three equations. X forces adding to 0, Y forces adding to 0, and Z forces adding to 0. The first thing we want to do is express these forces as vectors. We're going to have F1 equals the magnitude of F1 times a unit vector along the direction of 1, and similarly F2 will be F2 times a unit vector in direction 2, and force F3 vector will be F3 times a unit vector in direction 3. What we need to do is get these three unit vectors, U1, U2, and U3. Let's start with U2, that's the easiest one. That direction vector, F2, is pointing in the negative x direction, so that means the direction vector, the unit vector for force number 2 is in the minus I direction. The next easiest one to handle is force F1. So I've drawn this force from the side view, and here it is. And you can see that if I make a unit vector length of 1, that the z component will be 3/5 and the y component will be 4/5. So the unit vector for force 1, U1, will be no x, it'll be 0.8 in the y and 0.6 in the z. Lastly, let's get the unit vector for force 3. Looking at the side view of this vector, and it's also a 3, 4, 5 triangle, but this time 3 on the horizontal axis. You can see that the z component of a unit vector will be 0.845. So U3z will be 0.8. Now we need to look at the top view to get the x and y components, but the x and y components have to add up to a magnitude of 0.6. Okay, the z component was 0.845, and the xy component was 0.635. Now let's look at the top view of this. You can see that the xy component was 0.6, and that needs to be broken down into the individual x and y components. The x component will be 0.6 is the component times the total length, which is also 0.6 or 0.36, and the y component will be 4/5 or 0.8 times the xy component, which is 0.6, which is 0.48. We need to get the signs. The x is going in the positive x direction. The y is going in the negative y direction. And finally, the unit vector for force 3, E3, is 0.36 in the x minus 0.48 in the y plus 0.8 in the z. Let's go back to what we were doing. Here's the original picture of the problem with F1, F2, and F3, along with that 600 Newton and 900 Newton force. Let me also write down F1, F2, and F3 in their unit vector form. So here they are. Paste them right in, F1, F2, and F3. I'm back in my office now, so there's no more road background noise. What we need to do is take the three equations, sum fx equals 0, sum fy equals 0, and sum fz equals 0. Except in this case, we can't say right is positive, up is positive, because it's 3D. So what we're going to do is just take all the I components, complete with their sign, for the x equation, the j components for the y equation, and the k components for the z equation. And there are 5 forces. There is F1, F2, and F3. There's also this 600 Newton in the x and this 900 Newton in the minus z direction. So let's start with sum fx equals 0. We're going to go through the equation and just the equations for the forces and looking at the picture and write down all the x components. So F1 does not have an x component. F2 is in the minus I direction, so I'm going to write minus F2. F3 has 0.36 times F3 in the positive I direction, so I'm just going to write 0.36 F3. And looking at the picture, that 600 newtons is in the x direction. I'm going to write plus 600 for that. And that 900 newtons is in the z direction, no x component. So that all adds up to 0. Sum fy equals 0. Repeat the process, but look for all the j components. F1 has a 0.8 j component, 0.8 F1. F2 does not have a j component, and F3 has a minus 0.48 j component, minus 0.48 F3. Looking at the picture, the 600 Newton was in the x. This 900 Newton is in the z. There are no applied y forces. That equals 0. Let's now move to the z equation. Sum fz equals 0. We're going to look for all the k components. F1, 0.6 F1. F2 is only in the I direction, and F3 has a 0.8 component in the z direction. And finally, that 900 newtons in the picture is in the minus z direction. Thus, minus 900 equals 0. And now we have 3 equations, 3 unknowns, F1, F2, and F3. And you need to solve these 3 equations for the 3 unknowns. I'm going to do it using matrices, and I'll put that into my calculator. Here are those 3 equations written in matrix form. Really, this is just algebra. You have 3 equations, 3 unknowns. You should be able to solve it either by substitution, subtracting equations. But for me, since I've taken Math 2250 linear algebra at a different university, I know how to solve these equations on my calculator using matrix methods. I'll just solve these set of equations and come right back. And I get this for my answers. I'll post another video on how to solve these. I'll even post a video on the cheapest calculator I found that's able to do this. But when you